like now. Okay, I'm Corinne.
I'm Ethan.
I'm George.
I'm Dharma.
I'm Xavier.
And the article that we're talking about today is investigating changes in calcium, phosphorus, alkaline phosphatase, and 25-hydroxy vitamin D after surgical repair of fractures of the femur or tibia. So the purpose of this experiment or study was to investigate the changes in all of those minerals after a bone had been fractured to see kind of what they did in the repair cycle or in the repair process and all of that. So yeah, because the recovery of bones, of long bones after a fracture takes a specific process to restore the structure and function. And these minerals listed in here all have very specific uses and everything in that process. So kind of going off of that, they each have very specific functions, which does somebody else maybe want to cover?
I mean, I completely agree with what you're saying so far, but yeah, they do have a lot of different functions. I did actually, as I was reading it, I was kind of like, I did notice like the calcium levels and the phosphate levels did increase during the repair section, but also the vitamin D levels and the, what's it called? Alkaline phosphatase actually decreased. They didn't decrease, but there was like no significant change. But I did read one part of the article that I thought was interesting and that kind of tied in with what we were like studying. It says here that the average serum level of calcium increased while the serum level decreased in the 25-hydrovitamin D and the dihydrovitamin D. In the second month, the calcium level decreased, but levels of the vitamin D increased. At the end of the third month, the calcium level was normalized. And I kind of just wanted to ask y'all a question, like, do you guys think that that kind of represents like homeostasis, like the increase and decrease of like the calcium levels and how it like goes back to normal? Like, what do you guys think?
I think it definitely does. I think one of the well, I know that vitamin D is kind of meant to keep calcium and phosphate from like overabsorbing or anything like that so that it maintains homeostasis. So I think that was a cool little catch that you got in there. But yeah, I thought something else kind of that I was reading through and I found was interesting is that 25 hydroics, or if that's how I don't know how that's how you pronounce it, but that one, it's a metabolite of vitamin D, which I didn't really know what it meant, but it's just an active storage form of vitamin D. So I thought that it was interesting that they used and measured that instead of just the entirety of vitamin D and the count and everything. Um, but yeah, and something else was the serum level. I didn't know what that meant, so I had to kind of look it up and everything, but it's the concentration of like whatever you're looking at in the blood, which is cool because I had no clue that that's what that meant. Um, but yeah, so I think it was cool that it maintained homeostasis, but that also that all of these are involved in the fracture repair and that they are like the four main ones. Um, but yeah, I wanted to ask y'all if y'all knew like the steps of fracture repair and then like which minerals kind of went with which step, or if y'all knew that. Let me know if you need me to repeat my question too.
No, you're good. I definitely think out of the parts, like I would assume like the reason why calcium and like phosphorus were definitely the increasing factors is because calcium has to do a lot with the bone strength. And if anything, like the average like beforehand, like before they were testing it, like they were looking in the ranges for the calcium, and the normal range for calcium was 8.5 to 10.5. And like as they were doing the experiment, like they noticed that it went from like 8.846 to 9.396 to like 9.876. So they noticed like there was a huge like dramatic increase in scale. And that can definitely probably result in like the kind of like reforming, kind of like remodeling, kind of thing with like, the bones like coming back together. That definitely makes sense more for like calcium and kind of like phosphorus playing along with that. I wouldn't assume really vitamin D would affect it as much. Like that doesn't really make as much sense to me logically. Um, which makes sense that it kind of just stood and there wasn't really like any huge like significance towards it. But what I did notice though is like I know we have the tables, but we'll talk about that later. But I did notice from table three that I found it interesting that there was a difference in the level of calcium serum and alkaline phosphatase only for like the male and females that got their femur fractured, which I thought was like interesting, like the 0.041, like on the 12th week. Like I just thought that was really interesting because it only applied towards the femur break and not the tibia break. Um, which I thought was interesting. Like, what are you guys' opinions on that?
Uh, yeah, that rose me my question too on like how is difference between male and female if like gender plays a role. And I researched it and it said gender does play a role in like bone healing due to like biological differences in hormones and bone density and metabolism. Like in the study, the researcher found that vitamin D levels were like significantly different between males and females after surgery, and that calcium and alkaline phosphatase levels show difference in fractures, but not in the tibial fractures. These findings suggest like the gender specific factors influence the way like bones recover over time after injury. Like how it also rose another question if like external factors play a role in the levels of like vitamin D. Because let's say you broke a bone and you go to the doctor might give you like painkillers, and that could be like an external factor. So does that play a role in vitamin D? Because we all know like vitamin D comes from like you can go outside, get vitamin D from the sun. That also plays a role. So with going back to like gender roles in it, one major factor is like the estrogen uh on how that plays a key role in like bone metabolism by reducing bone uh breakdown and promoting like calcium retention. These like that meant how like women, especially those in like let's say a pregnant woman may experience like a slower or weaker bone healing if their like estrogen levels are low. The testosterones and like compared to testosterones in men, it helps maintain the bone density, may contribute to like a difference in how their bones recover compared to the women. Another factor could be like the differences in the baseline or like the bone density and how like the bone is structured. Men generally have higher like bone mass and denser bones, which might like explain why their healing patterns differ from women. If men naturally have like more stored calcium in their bones, their bodies might not need to be like mobilized as much from the bloodstream, healing leading to like difference in calcium levels over time. And that kind of like answered my question of like if gender plays like a good role in recovery or like repair of the bone, because we all know like repairing the bones takes like between 4 months to like a year, and that's in like between steps from like inflammation stages all the way to like bone remodeling. And that rose like I question in how 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 can how can like outside or external factors influence like our consumptions and like food influence like how fast the bone can repair itself?
I think outside factors do play a big part in how we heal as how we heal our body. Like it's obviously if I feed my body with a bunch of like junk food and stuff, my body's not gonna have enough nutritions to be able to help my body heal over time, get those bones to be stronger and be able to repair where it needs to be repaired. Whether if I eat more healthier, more nutrient dense foods, I'll be able to heal properly. Like if I have low calcium intake, my bones are gonna have a harder time getting stronger. And obviously, if you don't go outside too much with your vitamin D levels, they'll be low. That's why we have oranges and orange juice, which are high in vitamin D, which can help get those nutrients that you are lacking. So I do think nutrients plays a crucial part in helping bone health and healing, as they help carry a lot of important minerals to help get the body stronger and get the body to where it needs to get back to essentially.
I definitely agree with what George said. Also in the article itself, like in the conclusion, it does mention that like it says like, however, in the light of the curative effect of vitamin D in the formation and mineralization of bones, it is suggested for patients with tibial and femoral fractures to get vitamin D supplement in the curative period. So they do still recommend that you do get vitamin D. They're not excluding it at all because it does seem like it has like an important factor towards like recovery. Um, but what I did like think was interesting, like even though they're like prescribing like taking vitamin D and still taking these like supplements, like why do you guys think it really didn't play a part towards like it increasing? Like why were the stats like on it not significant at all, even though there was like somewhat of an increase, like they still said there was like no significance to the overall like recovery of the bones. So I kind of just want to know like, I mean, even though like nobody really knows like what y'all may think like could be a leading factor towards like no significance with the vitamin D levels rising.
Just so I'm answering the right question. You're asking why like calcium, phosphorus, and like all the rest of the vitamins kind of like either played a role in increasing recovery levels, but they didn't have an overlasting effect. That's what you're asking?
I'm basically asking like why, because vitamin D didn't have really any significance. So like why maybe that didn't really have any significance at all. Like why do you think so, even though they would still prescribe it as like a form of medication?
Oh, well, I mean, from what I understand, like again, all of them like calcium, phosphorus, and alkaline all like contribute to helping with recovery. But vitamin D apparently is like a key player in like calcium metabolism and bone healing. That's what it helps like mainly. But it mostly just pairs up with calcium and helps all these we can get if we intake too much calcium. So it's more vitamin D helps more as like regulating and the intake of it. So that's why, like, again, like, let's just say, like, I take twice as much calcium or vitamin D that I'm really prescribed to really have. Like, I
I
won't see a
didn't
big
I
increase,
didn't mean to cut
but
you
yeah,
off. I'm not
yeah,
sorry, Zach, I didn't mean to cut you off, but you did, for me at least, you cut out more than half of that, what you were saying. Do you mind going back and saying what you were saying earlier? I'm sorry.
yeah, no, of course, yeah. Basically, what I was saying was that vitamin D is like it's like a regulator. It's like an intake. It's like the pipe to like kind of like intake, the calcium, phosphorus, and basically filters everything. So it's not really much of a booster. So like for example, I was saying if I take vitamin D like any type of prescription that's I'm taking twice as much as I'm prescribed to have. It will help in the long run, but it won't give like a boost. Like we're kind of talking like we're asking like why wasn't there a certain boost? Because again, it's more of a regulator according to the article rather than like a significant boost there. So think of it as in like basically having an energy drink. You know what I mean? Like it'll give you a boost, but just because you take energy drinks every single day doesn't mean like your overall energy levels are gonna just increase. It's gonna just boost it rather than you seeing a significant improvement. So I guess that's if that answers your question. But yeah, that's what I've gotten from the article.
No, yeah, you definitely answered my question. I kind of wanted to go now like towards like the research area. What did you guys think of the tables and like the significance? I know we kind of like dabbed a little bit in table three, but what do you guys think about like, that the results from the calcium, phosphorus, the phosphatase, and the vitamin D? Like, what did you guys pick up on the informative tables?
Um, kind of picking that off with what we were just talking about, vitamin D, you can see on table one that out of all of them, it was the only one that like decreased and then kind of increased back again. And oopsies, sorry. Like it went from 26 to 21 and then back up to 22, which is kind of it, I guess, you could say like stabilizing back out. But in regards to that, I know Xavier just was talking about how it's kind of like our facilitator or whatever between calcium and phosphate and all of those other things. But I was gonna ask y'all, why do you think it went down first and then kind of steadied back out? Like what, because like Xavier was saying, like we don't, you can take a bunch of something, but it's vitamin D is our thing that's gonna facilitate. So why do you think it decreased so rapidly and then slowly started increasing again?
That's actually a good question. Uh, I honestly don't know. I mean, if we're taking a wild guess, um, I would say just like anything else, um, once you start taking a supplement of anything, your body has to adjust to it at first. So obviously, your body's whatever levels you're measuring, whether calcium levels, vitamin D levels, is gonna regulate at some point. But then once it really gets filtered in the body, and again, like the immune system metabolism actually intakes it, I think that's when we see the change. Now, as far as it going down, if we were just taking a straight shot at it, I honestly don't have an explanation why, but I think that would be my guess why. I guess just the body trying to regulate it. Again, it's not gonna at first accept it, but I would say like over time, once the metabolism kicks in, your body's immune system's kind of okay. Hey, this is here to help us, not hurt us. I think that's where the boost comes in. If you want to call it that. So yeah, that would be my guess.
I also don't have like a for sure guess, but I was just like looking at the article trying to see as Xavier was talking, and it could be about like what Donald was talking about earlier, because they said that the serum results were compared between males and females. Results showed in table 2. In addition, this table provides a mean and standard deviation of the serum levels divided into the sex group. As can be seen from the table, there's only a significant difference for the vitamin D after the surgery between the two sex groups. So it could be like a hormonal thing. Maybe one sex group needs a little bit more than the other. This is just all a wild guess, but maybe sex has to deal with how much input and output there could be towards the calcium, phosphorus, and all the things that are necessary for the recovery.
If I had
um
to take a guess, for me, I think the main reason, kind of like Zero said, kind of like that boost, when you break a bone, your body is trying to basically repair itself. It's trying to realign all the bone by growing more bone tissue. And during those like early stages, the bone tissue is very weak, very weak. So the increase in vitamin D, I think that's why you see a big increased spike in vitamin D, because vitamin D is trying to help the calcium and phosphorus help really get the regroup the bones together and help strengthen the bone tissue, which you kind of see in those 6 weeks where it kind of decreases. Once those bone tissues are all realigned, the bone is basically around like 90% of its original structure. I think you get that like initial that decrease after the 6 weeks. And I think why you see a slight increase after 12 weeks is mainly due to kind of the vitamin D kind of doing like, I guess, like management, like making sure everything's back in its places, making sure it has healed properly and is back to what it was supposed to be. So that's my guess on why. But if y'all want to add anything,
Yeah, I would agree with that in like some sort of way, because what you said like in the beginning, when you first like it will send like blood cells to that certain areas, like I said, is gonna start first with inflammation. So it wants to send the blood cells and at least try to re like re-repair it in some sort of way, which is why vitamin D is at 23 um uh compared to like after 6 weeks, maybe when it's like crystallizing in some type of way, like trying not use as much of repair, just trying to like let it breathe for a second. And then at the end, where like you start like trying to, let's say you're going to like therapy and you're actually trying to move and trying to like regain ability to use that specific type of movement or your bone, then maybe you're sending more cells to it to like get used to the pain or like the new movement they're trying to regain in some sort of way.
yeah, I agree with that last part completely. Usually after 6 weeks, for most people, that's when like for a broken bone, you tend to start physical therapy in that like 6 to 12 week range once the bone is almost healed properly. So I think why you that like that increase you said, I think it's just like the vitamin D kind of strengthening the bones to be able to withstand the support of the movement you're trying to teach through physical therapy. Because you got to remember, like that's new bone tissue that just grew. That just grew. It's new. It's still fresh. It doesn't quite know the movement patterns and also the kind of the weight you have to be able to hold. So by doing PT, by having the increase in vitamin D to help strengthen through physical therapy, I think is a reason why you see that slight increase.
I completely agree. I was gonna ask like a follow-up question, like, after basically viewing this experiment, like, what do you guys believe this could be used for with like further research in the future? Knowing how much like, all of these apply, what can we see in maybe in the future that these can be applied to, or kind of like, tracking results and seeing differences?
So I know for my profession, physical therapy is really big on this. Especially because funny enough, we actually do a lot of broken femurs, bones, clavicles, and all that type of stuff. So I'm going to a patient like, hey, look, your muscles are fine. It's really just your bones that need help and need a boost. I would give this chart to them, the article, like, hey, look, we've done research studies on calcium, phosphorus, alkaline, and then vitamin D and what supplements help and what supplements, don't do the best. Here's what I would tell you you should take. You can also look at the statistics yourself and just see like how to take care of your bones, like the bone structures and again, what supplements actually work and what don't. And then again, if I especially have like a male or female and they're more concerned about, let's just say like they're pregnant or they have like a iron deficiency and they're concerned with supplements like that, like I would again use this, not just the tables but the article itself to kind of explain my reasoning. So as a physical therapist, there's a lot of things I can benefit from using this article in my opinion.
Yeah, I completely agree. Something I noticed was that they took into account like obviously there were 68 patients and I think 34 of them, yeah, 34 femur, 34 tibia or whatever, and then they even went into describing like the male and female and everything. But then they also included the ages and they ranged from 2 to 69, and I think that was cool to like have a good variety in there. But when the statistics came out and like the results or whatever, nowhere was like age mentioned. And I think we all know that like the younger you are, the faster like things kind of heal, especially fractures and everything. So I think kind of like being PT and wanting to work with kids or whatever, I think it would be cool to see the results of like how age kind of varies with the results or how the results kind of vary with age. Um, like are the levels just super like are they a lot higher in kids and that's why it goes faster or stuff like that. But I think if we knew like the answers to those kinds of questions having to do with age, there could be, I mean, I don't even know, like not medicines necessarily, but um like vitamins and supplements and stuff that could be used in older patients to kind of revert back to that childlike healing almost. And working with all of that, but it would have been cool to see some sort of results with like age and stuff thrown in there just because it was mentioned but not put in there. But yeah, I don't know, not necessarily application, but if there were results for that, it would be cool to see how they um could be used for other things and helping people of all different ages because of the whole timing, the difference in the timing and all of that.
Yeah, I think without having the ages, it kind of skews the results a bit. Because as we know, if you are younger, when you're younger, your bones typically do heal faster. And then usually past around age 30, 35, that's when your body starts to slowly deteriorate and your body will age, which makes it harder and harder for it to heal. So I think by not including the ages and splitting it up, because you got to remember the age range between this is from 2 to 69, and I think by really not splitting it up, it kind of skews these like data metrics. And you know, if had they split up, we could have seen the impact. Had there been a greater impact on older older people, or was the impact very minimal for the younger group? I think they definitely should have split this up into an age. That way we can get a better idea of how much these supplements played an impact. But other than that, I do think it's a good way to show people what supplements that they need to take to be able to help heal.
Well, not only that, would you guys believe that, maybe the information would also be more accurate? Because like, like it's very broad what they're giving right now. Like, what if they narrowed it down to each kind of like age group? Like maybe they might get like more accurate information for like each kind of like age group you're in.
Yeah.
Like,
Yeah, I would say age is definitely a factor again, like she was saying earlier. When we're younger, our bones can repair a lot faster. We have a higher calcium kind of basically like, and I think it's almost like sawdust at that point. So like we get a minor fracture, it's basically like for us is like snapping like our tibia in half by like 4 times. So I think age is definitely a factor. Like she said, it didn't tell us what age range there was, but that would definitely be a factor in the calcium and vitamin D levels. So
Yeah, and if they were to like split into like age groups, future plans for like orthopedic treatments, they could like vary in like who needs like more calcium intake. Like if a 18-year-old breaks a bone compared to a 65-year-old, the 65-year-old is gonna need more calcium intake and more like treatment or um medicine to like deal with pain or to fasten the recovery. So if they would have branched out or like tried to divide it through ages, I know they only had like 68 people do it between the males and the females. It will help in some sort of like trying to figure out later on in the future for the plans and how diet, medication, and how lifestyle factors can benefit the recovery.
I completely agree. One thing I was gonna ask you guys, do you guys maybe have like anything you guys thought was like really interesting in the article? Was there something that maybe reached out to you guys or like any questions, concerns you guys might have that was like in there that you want to talk about?
I had something towards the very end, and I think like the discussion or the conclusions thing, it talked about relating like the present study to like other current studies that have been done and going on and all of that. And it showed that calcium and phosphorus aligned a lot with the other studies on like a short-term basis, but long-term they differed. So like I think the name of the person conducting one of the other studies was Sato or whatever. And it showed like together they showed that calcium like it increased short term, like up to 2 months. And for the present study that we're kind of reading over, it dropped, or I mean, it continued like increasing past 3 months and like ongoing. But Sato's study showed that it dropped after 2 months. Um, so that one was kind of confusing to me. Um, that calcium and phosphorus kind of differed in the long term, but then vitamin D and alkaline phosphatase were more consistent with the existing studies. So like I thought it was interesting that our study that we're kind of learning about and talking about has like a continuous calcium increase, but the other ones don't. And they have like a sharp drop off at 2 months. So like what happened at 2 months, or like if our variables are different than theirs, if we have more younger kids or older people or whatever, like I was curious about like the variables that were going into each study and how they differed, not just in the results, you know?
Yeah, I definitely agree. I definitely agree on the fact that it could have been the variable. It could have been where it was done, the environment. It could have been, there's a lot of different factors, how many people were involved. If, age group, like mental health, like there could have been a lot of other factors that could have affected it. And I definitely think that's a good thing you pointed out. In reality though, like, I mean, an experiment could be done, the same time, but if the environment's different, there could be different results as well. Um, but that's just my take on it. Maybe the variables were completely different.
Um, I think we've gone over every other table but this one. So kind of going along with what Ethan was asking, like, did y'all find anything, was there anything that y'all had like questions on or found like extremely interesting or whatever? But in particular, did y'all find anything that was like kind of unique or something to this slide and what all it encompasses? We might have already talked about it, but it's just like a mix of the sex group and the fracture types.
Yeah.
So tables 2 and 3.
It was basically that was what I was mentioning earlier. Basically that was just talking about like the phosphatase and like the male and female sex groups being affected by it. And that was with the femur break. Um, that was definitely like a lot of the results were very averaged out except for the week 6 and 12, and that was that recovery period. Where it was just there was basically not, it was more than the initial level and there was like an increase in it. It wasn't consistent and oh, sorry, there wasn't an increase. It was less than the initial level. Um, so that could have been just like, a random factor that I didn't really dig into. I don't know if you guys caught it. But yeah, that was the main difference was just like, it could have been just a decrease in level. Something could have happened. It could have been environmental. I don't know what you guys think.
Yeah, for at least this table, you can see how most of the numbers for tibia is lower, or like at least in some type lower than the femur, because it brought to a question that I was gonna ask, and like, is there like a difference in like healing speed or like recovery between the femur and the tibia? And I realized like the variation between the femur and the tibia fracture reveals like a different bones healed at a different rate and requires distinct approaches to like surgical care. Like the femur being the largest and the strongest bone in the body generally heals more quicker in some type of way due to like its rich blood supply and the way it aids in this fast recovery process. This allows like more of like a predictable or like a higher calcium intake in how the rehab like the recovery aim to like improving the muscle strength and the flexibility and the kind of compared to tibia, and how that's has like a limited blood supply, especially in like the distal region present for like more of like a challenge to it getting broken. Do y'all think that do y'all think that it has like a difference in type of healing between the femur and the tibia?
Wait, can you repeat it one more time?
Like compared using like how like size compared from the femur and the tibia, is there do you think that there's like difference in like recovery?
Absolutely. I think because obviously one's like basically the width of our pinky, and the other one's basically like again way bigger, twice the size of it. There's definitely gonna be a difference in recovery process. Um, so yeah, I mean size is always a factor. You know what I mean? Even though they're relatively the same length, it's just the width. The width makes that much of a difference. So I would say yes. And then with that, that'll probably have to be the last thing I have to comment on. I do have to go in a second. Yeah.
I got to know, what are some limitations y'all think this experiment showed that you think if we were to continue doing something this, what do you think they'll have to change to be able to make this more accurate and better for better use for?
That's a great question. I think um including like a different result portion for like the difference in ages or whatever would have been cool to see for future application of everything. Um that and then kind of I know it's difficult to like know who's going to break something and then measure it beforehand, but I think some sort of before like gathering of what we measured today, like the bone markers or whatever of all of the minerals that they tested on. I think a before of like what it normally looks like in the bone, like before it's been like broken or fractured or anything like that, like having a base to go off of and then to see it drop and then rise or drop and then whatever it does after it's started its healing process. I think including that in the research would have been cool, but it's kind of different per person and you can't like measure it on one person and then have them break a bone for the purpose of a study. So I get why it wasn't included, but if there was a way to make it happen, it would be interesting to see like a before and after kind of on how much a particular body holds before it fractures and then what that personal healing process looks like, that sort of thing.
I think for me, one thing I would like them to do better next time is probably like expand the sample size over more patients and over like a bigger time frame. Yeah, I know 68 patients between December 2018 to March 2019 is like good enough time and good enough people, but relatively it is still a pretty small sample size, especially if you want to do something like this and see how much of an effect it has. I think how they did, 200 over like a 5-year span, better idea of what kind of, I guess not 200, but 200 plus patients over that span, and these supplements, like the better effects it would have. So I think over this like short period of time, the numbers could either be higher or lower than what it should it should show. So I think the small sample has kind of limited it to these type of numbers. So I think if they're able to expand it out more, get more patients. I know it's hard to have patients that have all broken a femur or tibia, but I think by having a greater sample size, the data could be more accurate.
On my end, I would definitely say if it were me, I'd run the experiment differently by age group. Maybe be more precise towards the age group just to see different results and see maybe faster recovery time when for younger people and then maybe a slower recovery time because everything does slow down the further we age. So maybe that could have been like a little skew up in the, experiment, but definitely in the future, I'd definitely try to maybe be more precise and get more accurate results by, narrowing down the age group.
I think
Yeah,
what you want to go? Yeah, I'll let you go first.
yeah. For I was agreeing with you, George, and how you said getting like a bigger population size because 68, that might not be like, at least for me, as I went to like in my genetics class, it's talking about more than 100. That's a large population. So 68, that's pretty small. Um, so yeah, increasing that type of size and dividing by age group will make more sense in my eyes.
I think one more thing also, as I was reading this, I realized that they never really specified how much the patients use the supplements, which I think could really have harmed the data because you don't know if a patient was taking more supplements or a patient was taking less, which again makes this data kind of skewed and not accurate. So I wish next time they do this that they'll be able to have all the patients take the same amount and we know and to be able to say how much amount they took. That way again, this data can be more accurate to what it is. Because by just keeping it vague and saying they took these, we don't really know how much of their intake they would have done.
Does anybody have anything else or questions, interesting thoughts? No? Alrighty. I'm sure Xavier's good too. I think that'll conclude the end of our roundtable. Should I stop recording? Okay.